what to do when the limits tend to infinity, as in x tends to infinity. It talks about questions where, suppose you pay, apologies for that, $1,000 for every credit hour, but more than 15 credit hours, you pay $15,000. So even if I'm taking 19 credit hours, I'm still paying $15,000. If I'm taking 21 credit hours, I'm still paying $15,000. So initially, the price was rising, but when the credit hours rise indefinitely or beyond 15, the price remains the same. In that case, limit when x tends to infinity, price of your tuition fee tends to $15,000. Now, a good concept to remember when we are dealing with limits and infinities would be when limit x tends to infinity, 1 divided by x raised to n would turn out to be 0. And when limit x tends to negative infinity, the same thing comes into play, and 1 by x raised to n would again be 0. These two topics are important because often they turn the entire calculation into 0, which would just reduce the number. How to evaluate limits involving infinity? To evaluate limits involving infinity, start by dividing the numerator and the denominator by the highest power that occurs in the denominator. And whenever possible, apply the given formula mentioned before. For example, in this question, the highest power of the variable in the denominator is x squared. So we'll divide the entire function, each term in the function, by x squared. This would turn out the following way, which eventually becomes of this form. Now, if we apply the previous logic of using limit x tends to infinity, 1 by x raised to n is equal to 0, the following terms will become 0. If all these terms become 0, we're eventually just left with 3 by 5. So final answer is also actually 3 by 5.